Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions. The mystery of the Great Filter, why we haven't found alien life may be the worst news possible. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction. Not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. In 1950, physicist Enrico Fermi asked a question over lunch that has haunted science ever since. Where is everybody? The universe is 8 billion years old, filled with hundreds of billions of galaxies, each containing hundreds of billions of stars. Many of those stars have planets. The conditions for life appear common, and yet the sky is silent. No signals, no megastructures, no visitors. Nothing. In 1998, economist Robin Hanson gave the silence a name, the Great Filter. Somewhere along the path from dead chemistry to starfaring civilization, something stops almost everything from getting through. The filter is real, the silence proves it. What we do not know is where it sits. If the filter is behind us, buried in our deep past, we may be extraordinarily rare survivors of a nearly impossible gauntlet. That would be cause for cautious hope. But if the filter lies ahead of us, if it is nuclear war or artificial intelligence or something we have not yet imagined, then the silence of the cosmos is not merely strange. It is a warning, and the discovery of even the simplest microbial life on Mars would be the worst news our species has ever received. Why? This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms, unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from the predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies. The precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades, and patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding the Great Filter, why we haven't found alien life may be the worst news possible, is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Robin Hanson proposed the Great Filter in 1998 in a paper titled The Great Filter. Are we almost past it? The filter is defined as any step in the development of intelligent, spacefaring life that is so improbable it explains why the observable universe appears lifeless despite its vast age and scale. The filter does not have to be a single step. It could be the combined improbability of many steps. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes, but as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered candidates for the location of the filter span the entire history of life. The origin of life itself, abiogenesis, chemistry spontaneously producing self-replicating molecules, the emergence of complex eukaryotic cells with a nucleus, the invention of sexual reproduction, the evolution of multicellular organisms, the development of complex nervous systems, and the appearance of technological intelligence itself. Each represents a step that may have occurred only once. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine if the filter lies behind us. If one of those past steps was vanishingly rare, then we may be alone or nearly alone in the observable universe. The silence of the sky reflects not extinction ahead, but the extraordinary improbability of our own existence. We are the lottery winners, the statistical outlier in a cosmos that almost never produces minds capable of asking the question. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, if the filter lies ahead of us, the implications are reversed and far more disturbing. It means civilizations routinely arise, develop technology, and then collapse before they can expand. Nuclear weapons, misaligned artificial intelligence, engineered pandemics, or climate collapse become not merely dangers, but near certainties. The mechanism by which the filter eliminates civilizations before they can leave detectable traces in the galaxy. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the Milky Way is 13.6 billion years old, a civilization that arose just 1 billion years before us and expanded at even 1% of the speed of light could have colonized every star in the galaxy within 10 million years, a fraction of the galaxy's age. The complete absence of any such presence, any megastructure, any signal, any artifact demands explanation. The galaxy should be full. It is not. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. Breakthrough Listen, the most comprehensive SETI survey ever conducted, used the Grain Bank Telescope and the Parkes Observatory to survey 1 million nearby stars over 10 years. It found no confirmed technosignatures, no artificial radio signals, no laser pulses, no structured electromagnetic emissions of any kind attributable to intelligence. The silence held across a million chances to hear something. Taken together, These facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Great Filter. Why we haven't found alien life may be the worst news possible. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the filter is the origin of life. Abiogenesis is so extraordinarily improbable that it occurs perhaps once per observable universe. Under this view, the chemistry that produced the first self-replicating molecule on Earth was a freak event billions of years in the making. The objection is that life appeared on Earth very rapidly after conditions allowed it, suggesting abiogenesis may not be as rare as the hypothesis requires. This interpretation has significant academic support and is backed by substantial evidence. But it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the filter is the development of eukaryotic cells, the endosymbiotic merger between an archaeon and a bacterium that produced the nucleus, was a near-impossible one-time accident. As argued by biochemist Nick Lane, simple prokaryotic life may be common throughout the universe, but the jump to complex cells is the wall almost nothing crosses. The objection is that this event, too, occurred relatively early in Earth's history, which may undercut the improbability claim. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the filter lies ahead of us. Technological civilizations tend to destroy themselves before achieving interstellar reach, through nuclear war, artificial intelligence alignment failure, or climate collapse. A separate variant, the transcension hypothesis proposed by John Smart, suggests civilizations do not expand outward, but inward, into virtual existence and miniaturized computation, making them permanently invisible to radio telescopes scanning for physical expansion. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Great Filter, why we haven't found alien life may be the worst news possible, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the age of the universe combined with the complete absence of megastructures, Dyson spheres, or artificial signals constitutes the foundational evidence for a filter of some kind. The Fermi paradox is not merely a puzzle, it is a quantitative argument. Given the age and size of the galaxy, the absence of detectable civilizations requires either extreme rarity or near-universal destruction, with no middle ground. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the discovery of simple microbial life on Mars or in the subsurface oceans of Europa or Enceladus would not resolve the filter question, it would sharpen it dramatically. If life arose independently twice in our own solar system, then life is common throughout the galaxy, and the filter cannot be abiogenesis. It must therefore lie further along the path, past simple life, past complexity, closer to intelligence or technology. The filter moves forward, and we move closer to it. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed. Breakthrough Listen's 10-year survey of 1 million stars found no technosignatures. The Fermi paradox calculation. Even at 1% of light speed, a civilization could colonize the entire Milky Way in roughly 10 million years, negligible against the galaxy's 13 billion-year age. Nick Bostrom's 2008 essay Where Are They? Formalized the argument that a Mars fossil discovery would be, in his words, the worst news ever printed on a newspaper front page. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Great Filter. Why we haven't found alien life may be the worst news possible. Now, we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. The Great Filter remains the most consequential unanswered question in science. JWST is now analyzing exoplanet atmospheres for biosignatures, oxygen, methane, water vapor in combination. The first confirmed detection of life chemistry on an exoplanet would force a reckoning with the filter's location. Nick Bostrom's essay made the stakes clear. If we find life elsewhere, the filter is ahead of us, and we are probably doomed. If we find nothing, we are probably alone, and the weight of the cosmos falls on us. Neither answer is comfortable. The question is not academic. Every dollar spent on AI alignment research, pandemic preparedness, or nuclear nonproliferation is implicitly a bet on where the filter sits. The silence continues. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Great Filter. Why we haven't found alien life may be the worst news possible. From the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Great Filter ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.